training webinar for Celigo. As she mentioned, we're going to talk about the Caspase and Hoechst assay on Celigo. This is a really easy assay, and it's what I would call a clean assay, not too difficult. And that helps that we're going to use Hoechst to identify our cells. Even though the cells are looking kind of sickly with the drug treatment, you can see in this bright field image, the idea is to identify the cells that have the green stain. So we use Hoechst as our marker. So first off, I want to go over the content that we're going to cover in this training session. I'll tell you about how I prepared my plate, how to acquire the images on Celigo, how we do the image analysis, and then we'll do some gating, something new and tricky sometimes for people. And then we'll review the results on the results tab and show you how to export the data and what you're looking for in the export of that data. Okay, so let's see. The first thing we want to do is talk about the protocol. So for today's training session, I've got a plate map that's just kind of a general plate map. You can put whatever you want in your plate, so this is just a guidance. I typically use a 96 well plate, and in 100 microliters, I'll plate for adherent cells about 10,000 cells per well, and I let those adhere overnight. And then on the suspension cells, I usually plate that on the day of treatment, and that's about 20,000 cells. So that's how our plate map is designed today. So then you're going to want to add the drug treatment, and so the next day on after the overnight adherence, you'll come in with a 2x drug treatment, and you're going to add 100 microliters of this 2x drug working solution to the wells. And then you'll want to incubate your cells for, in this case I used staurosporin, so for 6 hours this allowed the cells to go get some apoptosis, destruction. So then after the 6-hour treatment, I prepared a 2x dye solution of Caspase and Hoechst. And then I removed on the plate, I removed 100 microliters from the well, which was containing 200 microliters. And then I added the 2x dye solution at 100 microliters. And that becomes a 1x once you put it in the well. And then I incubate this for 30 minutes in the incubator. Then you'll image on the Celigo. Now, as an alternative, you can do an add-only assay. So instead of removing the media or the content and adding in 100 microliters, you can prepare a 5x concentration and add 50 microliters right on top of the 200 microliters. So let's image on the Celigo. So here in the Start tab, we're going to create a new scan, which is the first button. And then we're going to select the plate category. So these are all different well formats. Here we have a 96 well plate. And then we need to select the vendor type. So this is a list of all the manufacturers and catalog numbers that we've currently got provided, and it's in alphabetical order. So we're looking for a Greiner 655090. This is the black wall clear bottom plate. And then we'll give our scan or plate an ID name. So this is kind of like giving your document a name. So we'll call this Caspase 37 Apoptosis. And then we click Load Plate. At this point, the stage opens, and you can put your plate on the stage and tuck it into the corner A1. And then you just click OK, and the stage will move back into the system. And we'll move over to the Scan tab, or it automatically moves us into the Scan tab when you click OK. And you'll notice the first thing we have to do is select the application. That's the only point that we have access to. So in the drop-down menu, there's a lot of applications you can do on Celigo. And this one's kind of unique. I want to actually image more than just the green and blue channel. I want to do bright field. So I'm going to go to the Expression Analysis Suite and image with the target 1+2+ mask. This way I can capture a bright field image in addition to my green and blue channels, but I don't need to analyze them. All right, so let's customize these channel names instead of target 1+2+ mask. This is very generic, but if you use this little button up here with a little hand on a piece of paper, you can actually rename the channel names and the feature names. So you just highlight the word target and give it something more meaningful. So for channel 1, I want to do the green image. Channel 2 will be our bright field image. And channel 3, which is our mask channel, will be blue for our Hoechst stain cells. And the feature is actually what is being detected on the Analyze tab. So that's a feature. We'll keep the word mask because I want you guys to understand that's what we'll be looking for in the Analyze tab. And then just click OK. Okay, so now let's change the channel so you can see our names are relabeled with our new names. And let's change over to the blue mask channel. And then we'll want to select a well or click on a well in the navigation mode, which is currently highlighted light blue, and click on a well. Let's go to B2. And the illumination we need here for the blue channel is blue for this Hoechst stain. The default illumination is at 10,000. So if you just click snap, you can see how is your content in the well, the Hoechst staining, looking. 10,000 is too dim. I know for the protocol, you'll need about 60,000 exposure. So if you click snap after you type in 60,000, you can see there's content there. It's out of focus. So let's go and set up the focus down here. Focus Setup opens up another dialog box. And the only thing you'll need to do here is click Register Auto. The system will move the stage up and down like you would do on a microscope and trying to find the right cell, the Z-plane where the cells are in focus. So you can see your cells will eventually stop at the point where they're in focus, and then the hardware focus beams, which you don't see, will be placed on the bottom. So now we're going to be using those hardware focus beams to find the right focus when you navigate from well to well. So we can close that dialog box, and then just with your scroll button you can zoom in to see the Hoechst stain cells. Now at this point I want you to understand that the pixel intensity of the objects should be between 125 and 175. This is in the middle of the camera range, which is 0 to 255. And we want our objects, or the Hoechst stain cells, to be in the middle of that camera range. So just hovering your mouse over those objects displays the pixel down below. And so if you're not quite there, you can always up the exposure a little bit till you get there. Now let's change over to the bright field channel. And we'll also change the illumination at this point. The default always comes up with blue, but you'll change the channel illumination to bright field. And we'll use the auto calc. Auto calc works well in bright field. It does not work for fluorescence. And at this point, the auto calc returns a illumination exposure that returns a background pixel intensity of 125. Again, this is the middle of the camera range. So in bright field, you want the background to be in the middle of the camera range. And in fluorescence, you want the objects to be in the middle of the camera range. Okay, we're all set. We don't need to do anything with focus. They look great. And then we can go over to the green channel and change the illumination to green. And for this experiment and this assay, again, you can click snap to see what 10,000 looks like. There's not much there. I know for the protocol, you're going to need to turn up the exposure to about 60,000. And this is a treated well, so we should see some content. So change it to 60,000 and then click snap. This basically takes a picture, but it doesn't save it. But it, again, doesn't leave the camera on, so you won't have the potential to photo bleach your cells. And now I'll use Find Focus, which is to the left of the Setup button, to help me figure out the focal plane for where these cells are in focus. This Caspase stain is in focus. And you'll see the value above it, it says 27 microns positive from the hardware focus. So this is where we want to collect those images. So clicking Set Offset populates the number up here in the text box. And this means the hardware focus registration will occur first, then the blue image is taken, the system will move 27 microns positive, and then take the green image from there. That way both channels are in focus. Now again, You just want to make sure your Caspase objects are in the right pixel intensity. Again, you want between 125 and 175. And this dye actually is a nuclear stain. It will light up bright in the nucleus, but you might have some cytosolic staining, but it's going to be much dimmer compared to the nuclei. So focus on your pixels inside the nucleus area. All right, so we have set up the illumination and focus for all 3 channels. We are all set. And now we have to select which wells do we want to image on this plate. So clicking on this selection button in the plate navigation area, then highlight the wells that you want to image. And then click Start Scan. All right, so now the system will move over to C2 and collect the images for the settings that we just set up. And this page will move us over to Analyze tab. When an image has been saved, we can start viewing it and looking at the analysis parameters. So clicking on a well will populate one of the images. So for a 96 well, it takes 16 images per channel and will display currently 1 of those images. But all 3 channels are being displayed at once. So you can see how the cells look with the bright field. With the drug treatment, you can see how when the cells are sickly and the caspase stain is in the cell, they don't have a real good morphology on bright field. So bright field wouldn't be a good feature for you to do segmentation on. So that's why we're using the Hoechst stain to identify our cells. And so just turning on the different images, you can see how the bright field cells don't look so good, but the Hoechst stain is definitely right where the caspase stain is the brightest. And now the graphic overlay is what we're going to understand next. So currently you'll see that the green graphic overlay and the bright field graphic overlay both look the same, and so does the blue mask. That's because we're using a mask application where the Hoechst or the mask channel is the only object we need to define the parameters for identifying the nuclei. So we can just turn off those other 2, the green and bright field, and focus on the blue mask graphic overlay. Now, the top portion of this analysis parameter part is the well mask. And this is just basically defining the well outline so you don't identify objects outside the well wall. So if we click on the edge of a well using our well map navigation button, you can see that we'll see the images right up to, we'll see cells identified right up to the well area. And by clicking on the well mask checkbox and turning on the well mask overlay, an orange line appears. But first, let's check auto analyze. You can do analyze or checkbox this, so that means the graphic overlays will update every time you change a parameter versus clicking the button every time. So now you can see the well mask is right next to the well edge, and that means anything on the outside of the well wall will be ignored in analysis. Anything on the inside will be detected for objects in the image. All right, so let's move back over to the center of the well, or a part of it, and let's observe these identification parameters. Again, the graphic overlay for the mask is purely looking at the Hoechst stain, and you can see that we've got some cells here that are close together and they're looking like they're counted as 1. So we can separate this by separate touching objects, turn that checkbox on, and it should break up the objects that are super close to each other. Yep, it did a good job. All right. So if you end up having too much separation and it chops cells into 2 when it should be 1, then I would turn it off. But for the nuclei, that works really well. Now, the intensity threshold and cell diameter are the 2 parameters that I probably would focus on the most. But if you have set the illumination properly to the pixel intensity of 125 to 175, the default settings should work just fine. So 4 and 10 are there as default settings to get you started. And you can see when you lower the intensity threshold, you basically pick up more objects that are very faint and tiny. And then going back to the default of 4, you see it does a pretty good job. But let's, for just learning's sake, turn it up to 6. So let's pick up less objects that are only really bright, and you can see what happens. Well, there isn't much of a difference. The graphic overlay didn't really change that much. So that's why the default settings are 4 and 10. So if you have your illumination exposure set to give you that pixel intensity I talked about on the scan tab, the default settings should work pretty robustly for the nuclei. And again, the cell diameter, about 10, it says pixels, but remember our images are 1 micron per pixel, so that's 10 microns. And the nuclei has a size about that. If you have smaller cells like Jurkits, then you might want to lower it down to 8. But for these cells, this is a 231 MDA MB231 cell line. 10 is pretty good. And you can see when you move it up to 12, it didn't really change that much. It might merge some closer together cells. So let's stick with the default settings at 4 and 10. Okay. So I only turned on the well mask and did separate touching objects. And typically I do that a lot of the times for Hoechst. So at this point, we can click on the gate tab and it'll migrate us over there. And we'll just click on a well to start viewing it. Now, before we were looking at one image from the camera. Now it's stitched all of the images together, so we're seeing the whole well displayed at this point. Now, I'd like to actually open up this customized menu box. You can see where we changed the channel names and the feature names. Now I want to change the class from class 1 to Caspase 3, 7 plus or positive. And so this is the class that we're going to define here in the gating tab. We want to find the green positive cells, but we're going to use the outline that was defined from the Analyze tab. So now you can see the graphic overlay is in blue, and it's only looking or outlining the Hoechst nuclei. So within those circles identified, we're going to look for blue intensity from the mask channel and green intensity from the green channel in that little area defined by the outline, the graphic overlay. So you can turn on and off the images with these image display buttons. And what we want to focus on is the green and the blue image. So the first thing we'll need to do is click this green plus sign to help us create the plot. And in here, it's asking 3 questions. The source population will be all total, and the plot type, you have the choice of histogram or a scatter plot. We want the scatter plot. And then plot parameters on the x-axis, we want the blue mean intensity. And on the y, we want to have the green mean intensity. So this means the scale of the scatter plot will be within the camera range, which is from 0 to 255 for both the blue channel and the green channel. And now what we want to do is create a plot or a gate around those green objects. So let's click on the rectangle and then just draw a diagonal right over that population that is showing up in green, or at least elevated in green on the scatter plot. Now, if you turn on the graphic overlay, you'll see that any of the objects falling inside that rectangle are highlighted aqua blue. A little hard to see, so let's change it over to the red with this drop-down arrow. You can change the color to whatever you want. Now we need to check this checkbox. This is critical because this is what you're saying you want to be reported on the results tab. If you didn't check it, you would only see the total population. So please check the Caspase checkbox. And then this is a treated well. It has 3 micromolar staurosporin for 6 hours, MDA 231s. It's always good to have a positive and negative on your plate to help you understand where you should put the bottom of your gates to separate the population. So let's click over to a control well, and you can see how the population shifts. So the bottom half there is the control. And so you can see now I only have a few cells that are in that rectangle, and most of the population is below the gate. So, and if you want to move the gate down a little bit, you can use your left mouse button, click on the gate and just drag it down, or use the little squares on the corner of the rectangle and change the size and shape of your rectangle. And now clicking back to a treated well, you can see that it's holding with the replicates just fine. And that looks pretty good. Now, note, I am not showing the Jurkat cells because it basically is the same concept, but I pretty much wiped out all my Jurkat cells. You'll see that on the results tab. So today we're just looking at the 231s. So this is where you just click Start Analysis, and this gating parameters will be applied to every well. So this items we set up in Analyze looked at the Hoechst nuclei, and then the gating tab was identifying the Caspase positive cells in the nuclear area. So you can see from the Results tab that on the thumbnail images, the data is currently displayed. So you can click on any of those measurements, and that's the data that will be displayed on the thumbnail image. Okay. So right now the thumbnail image is actually the green Caspase image. If you wanted to switch over to the blue Hoechst stained thumbnail or the bright field, you would just change the channel display here. And then you can see that the replicates that I have here for the treated and the control are pretty robust. This is a good assay. You can use these min-max type treatments to calculate the Z factor for your robustness. So it's a good validation assay for validating in your lab. Okay. So we've got about 25% is the treated and about 1% or less, 0.5% on the control. So that looks pretty good. Now let's double click on any one of these wells. Let's pick a treated one, and it'll open up in the display area the high resolution image stitched together. So just using your scroll button at this point, you can zoom in on the image. Notice on the left-hand column the display of data. So you have the percent of the Caspase positive cells and then the raw counts, and those were identified from our gating tab. And the data below that is actually the channel mean intensity for green, bright field, and blue. And if you scroll further down, you'll see Caspase 37 positive green mean intensity. So that's actually only mean intensity from the Caspase identified cells from the gating tab. So the first section is from the channels, and then the lower section is from our gating. So all right, so zooming in, you can see that we have currently the graphic overlay for the class or the gate tab displayed. We've got total and Caspase positive. So that's where you have the blue is the total and the Caspase positive is the red. And just by turning off the bright field and turning on and off the graphic overlay, you can verify that it did a correct job. If you're not satisfied with your data output at this point and you're like, oh, I could tweak my gating a little bit better than that. So at this point, you'll notice that the gate is, the word gate at the top of the workflow is white. You can actually go back to the gate tab, make an adjustment to your plot and your gate, and reanalyze it. So you can analyze your scan as many times as you want. So as long as you have good images, good focus, then you can analyze the same data set as many times as you want. But I'm pretty happy with this. The controls look good. We've got good identification. There's very few cells in our control having a Caspase positive signal. So this looks good to me. So at this point, we can go back to the scan. This button here will bring us back to the plate level viewing of the data. So if everything is good and you're like, all right, this is what I want to make my report on, so then you can go over here to the button that says export well level data, and it will ask you to save this file in a location that you choose. I'm just going to put it on the desktop, and you can tell that the file name is actually provided. It gives you the scan ID, the scan time, and then the export or the analysis time. Okay, so at this point, let's take a peek at that CSV file. You'll notice at the top portion of this, there's a lot of detail about the plate. So the plate ID, what description I added in there in my own notes, the scan ID, what application did I use, what plate type, all that information. And then the first grouping is of the plate measurements is like we saw on the screen, which was the % positive Caspase. And then you have the counts below that, and then the total counts. And then down below further, well sampled is just, did I image the whole well or did I subsample less than the whole well, like only 4 FOVs or images? We did the whole well though. And then further down is the intensity values for the images. So at this point, we've basically covered the whole training session. I don't want to review what we've done. We've talked about how to prepare your plate, from plating cells, drugging and adding dye, to how to image the plate with proper illumination and focus. How do we analyze it using the mask? And then how do we gate to identify the green population? We reviewed the results and then did data export. So not too bad. It's a lot of content, but it is actually pretty easy if you've done this 1 or 2 times. Okay, so at this point, I probably want to open up the dialogue for any questions we have from our audience.
Thanks, Sarah. I think that was a wonderful presentation. So like Sarah said, we are opening this time for any questions that our attendees have for us. So feel free to type those into the questions bar for us and we can address those. While we're waiting, I'll give you guys a minute or 2 to type those in. I just want to remind you guys that we do encourage our attendees to submit any topic ideas that they have for future webinars. So if there's a specific application on the Celigo you're interested in seeing, a specific cell type you're interested in seeing being counted, anything like that, we'd be happy to hear your suggestions. You can email us, you can give us a call. There's a short survey you can fill out at the end of this webinar where you can type in your suggestions there. So any future topics you guys would like to see, we'd be happy to review those. So I'll just give you guys another minute or so to see if we get any questions that come through. Alrighty, so I'm not really seeing any questions come through. So I guess that will conclude our webinar for today. If you guys do think of any questions later on, feel free to give us a call or shoot us an email at support@nexlam.com. We'd be happy to answer any questions you guys have on this content or any other questions for the Celigo or our ceilometer instruments. Thanks, Sarah, for a wonderful presentation, and thank you all of our attendees for joining us today. And we hope you guys can join us again next month for our next Celigo user training webinar. We'd be happy to have you. I hope everyone has a great day. Thanks for joining.
Thanks, Amy. Thanks, everyone, for coming. Bye-bye.